Hi, I'm Dave from Blocky. Today, I would like to share how you can use our verifiable computing tools within the Kafka ecosystem. Specifically, many use the Kafka REST proxy to interact with Kafka. It allows applications to produce and consume messages to and from Kafka topics using standard HTTP requests. We will show how we can use Blocky's Attesting gateway in conjunction with the Kafka REST proxy to attest your application's Kafka operations. In this demo, we'll refer to the gateway as the Kafka connector. With that out of the way, let's jump in. First, let's explore some of the infrastructure for this demo. Using the Docker ps command, we can list all the containers that we're running. Kafka REST is the Confluent Kafka REST proxy. Kafka UI is a UI to monitor and manage Kafka. Schema Registry is a Confluent schema management tool, and Broker is the community version of the Confluent Kafka package. Recall that we can create a plain JSON topic using the REST proxy with following curl command. In the curl command, we add two records to the topic, one for Bozeman and another for Warsaw. Or we can add an Arvo topic with schema registry support using the following curl command. In the curl command, we add two records, one for Alice and one for Bob. Note the value schema ID is set for the messages. That means our Arvo topic uses a schema registry to enforce the message format. Now, let's try listing all the existing topics. For demonstration purposes, let's try to consume all the messages that we previously wrote in our plain JSON topic. Note that these operations are not yet attested. We need to do some preparations before the broker delivers these messages to us. Normally, these operations are managed by a Kafka client library. First, we'll create a consumer group that allows the Kafka broker to keep track of which topics and messages are already read. Second, we'll create a consumer instance and subscribe it to a group and topic so that the broker knows which topic we will read. Finally, we'll consume the JSON topic records. Here we see our output for the JSON topics for our values Bozeman and Warsaw, which we put in the previous step. Okay, so let's clean up after ourselves. We'll commit the offsets and delete the group. We'll repeat all the operations required to read messages from a topic, but this time for our Arvo topic. Let's start by creating an Arvo topic consumer group. Then let's subscribe to the consumer group. And now we consume our Arvo messages. As we saw before, right, from our Arvo topic, we have our Alice and our Bob records. Finally, we clean up and commit the offsets and delete the groups. Next, we will start the attestation gateway, also known as the Kafka connector. Whenever you make an HTTP request to the connector, it will forward that request to the Blocky attestation service, where the request response cycle will be attested. For those familiar with the BKYAS CLI, this functionality is similar to the attest API call subcommand, but it is more convenient for HTTP-based workflows. Note that the connector is intended to be run in your environment along with your Kafka infrastructure. Let's write to our plain JSON topic, but this time it will be attested. Notice that again we're going to make a curl request, other than the record values being different. The only difference is going to be changing the port that we're connecting to. Observe that the response consists of two sections, the attestation which contains metadata such as an enclave attestation, some public keys, a transitive attestation, some claims over that response. This data is used for verifying the integrity of the request and the response. In addition, we also receive the response. This is the base64 encoded standard Kafka REST response. We can pull the Kafka REST proxy response from the response section with a little bit of JQ magic. And we see exactly what we were seeing before. Now, let's do some attested writes to our Arvo topic. Similar to the JSON topic, we can see the attestation containing the metadata. See over here. As well as the response, which again, base64 encoded response from the Kafka REST proxy. Now, let's do some attested JSON topic reads. As before, let's start by creating a JSON topic consumer group. Note that here we went back to interacting with the REST proxy by using the port at 8082. This demonstrates that if we wanted to, we can selectively go back and forth between using the attested and non-attested calls. And then we can subscribe to the consumer group for the JSON topic. And now let's read our attested JSON topics and records. Note that here we're going to go back to using the 9090 port for the connector. And like before, we see that for the read, we have an attestation which has similar metadata that can be used to verify the reading at a later point, as well as the response that is base64 encoded. Similar to before, we can pull out of the output the base64 encoded response and see what we had. For example, in the JSON topic, we had the value whitefish and Krakow. Finally, let's clean up, commit offsets, and delete the group. Now we can do the same thing for our Arvo topic. We create the consumer group and subscribe, and then read. Once again, we have all the same metadata as well as the response. And we can look at the response and see that from our Arvo topic, Oscar, Arvo topic, Ernie. Great. So finally, let's commit the offsets and clean up. Similar to any of the tools within the Blocky ecosystem, we can demonstrate how we can use these attestations to verify the contents of these responses. So let's do an attested write and save the response. Now we can use the Blocky CLI to verify this response. To do so, first we're going to have to use JQ to extract some information from that response that we collected. And let's just first look at what that format is. All right, so we're going to form a JSON object that have the enclave attested application public key and the transitive attested API call. Right? These are just two of the strings that we pulled out of the output from one of those attestations. And then what we're going to do is pipe that to the bkyas command and run verify API call. And we're going to just pipe that output to JQ. And what this bkyas verify API call command will do is it will take this enclave tested application public key and the transitive tested API call, look at the information in them with respect to the keys, the signing, and the claims, and make sure that these all trace back to the correct environment and application that was run properly. If it does, it'll return successfully and give us back the output. If not, it will produce an error. And notice here, it returns a response with a successful response, and we can get back all that information that we had, such as the public keys, the claims, as well as information such as output from these, for example, contained inside the body, the base64 encoded data that we saw before. Now that we have seen how to use the Kafka connector along with the Kafka REST proxy, let's see how to use it in a more advanced way. Specifically, if one wanted to add verifiable operations to a legacy application, one would have to modify the input and output processing to include the attestation section and response decoding. Next, we'll see how we can configure the Kafka connector to be a drop-in replacement such that it sends attestations to a dedicated HTTP sink while continuing to provide the familiar responses from the Kafka REST proxy. Let's hop over to our connector and just kill the old one. And let's take a look at just a piece of the configuration for the HTTP sink, just at the bottom. What's particularly important here is that we specify a URL for where we want our sinks to go, the method that we're going to use. So here we're going to make a post for 127.80.82 topics attestation, and then what the body we want to look like, where we say attestation is for the value. One thing in this example that we're going to do is we're actually just going to write all of our attestations into another Kafka topic. However, you could write it to, for example, an HTTP logging endpoint or a database that has an HTTP interface, for example, something like CouchDB. Kind of it's up to you from that point. It just has to be an HTTP endpoint. But we're going to stick with Kafka since we have everything already set up for it for this demo. So let's get our server started with our config that utilizes the sink. And let's hop back to our demo shell. Now, let's write some messages and send some attestations to a dedicated topic. Let's do an attested write to our plain JSON topic. Note that the response does not contain any sections for attestations or responses sent by the Kafka REST proxy. This is exactly as what we were seeing in the beginning. Now let's do some attested JSON topic reads. We should receive only the messages that have yet to be consumed. As before, we create the topic consumer group and subscribe and perform an attested read of the JSON topic records. Note the different host and port in the URL. We're back to using 9090. Again, notice that we're getting responses that look like they did when we were talking directly to the Kafka REST proxy in the beginning. Okay, so finally, let's clean up. Since we enabled pushing of the attestations to a dedicated topic, we've had one write to the JSON topic and one read from the JSON topic. Thus, the attestation topic should contain two messages with our attestations. Let's read them. Like before, let's start by creating a JSON topic consumer group and subscribe to the group. And now let's read our topic. Right, so we get a list of a collection of attestations. Each one of them is its own JSON document. And so we can make sure that we have the correct number of attestations using some JQ magic. And we end up with 2, as we expected. So finally, let's clean up, commit some offsets, and delete the group. From here, you can take those attestations and verify them using the BKY AS tool like we saw earlier in the demo. So thanks again for checking out this demo of how we can use the Blocky verifiable computing tools within the Kafka ecosystem. And have a great day.